So, dear students, in the last lecture, we have finished what are the properties of eigenvalues and how to find eigenvalues of adjoint matrix A inverse and a constant multiple of matrix, and so many problems I did. So we also defined in the last lecture what are the characteristic vector or eigenvector of a matrix, and we did one problem based on that. So let us continue our topic eigenvalues and eigenvector of the matrix. So the next example is what? Find find eigenvalues eigenvalues and eigenvector eigenvectors of the matrix. Your matrix is given to you 3 cross 3 matrix, that is what? Row wise 1 2 2 0 2 1 0 2 1, and the next row is minus 1 2 2 minus 1 2 2. Okay, this matrix is given to you, and what have to do? We have to find out the eigenvalues and eigenvector of this matrix. So let us see how to find eigenvalues and eigenvector of this matrix. So solution. So first of all, what have to do? We just write down the given matrix. So what is the given to you? Given that your matrix A is equal to, just write down 1 2 2 row wise, and then the second row 0 2 1, and the third row is what? Minus 1 2 and 2. Okay, then what I have to do? Then find out determinant of this matrix. So what are the determinant of this matrix? Determinant of A is equal to 1 2 2 0 2 1, then minus 1 2 2. Expand this matrix. So we will have, I am expanding corresponding to first row. So this is 1 cross multiply 2 to the 4 minus 2 and minus 2, then cross multiply 2, and here will be 0, and minus here a plus 2 1 ja, sorry 1 1 1 ja 1 here, and plus 2, then multiply cross multiply, so you will get here 0, and minus goes plus 2 1 ja 2. Okay, just simplify this. So you'll have 1 1 and 2 minus 2 1 and plus 2 and 2. Again simplify. This is what? 2 and minus 2 and plus 2 to the 4. So this gives that 2 and 2, 2 and minus 2 will show, and you will get only 4. So determinant of the given matrix is 4. Now what? Now we have to find a trace of the matrix. Just write down trace of the matrix A is equal to what? Sum of the diagonal element of the given matrix. So that is what? 1 plus 2 plus 2. That is how much? 2 plus 2 4. 4 plus 1 is how much? 5. So trace of the matrix is 5. Okay. Now our job is to find out the characteristic equation. So for this, what up to do? We have to write down the formula for characteristic equation. So that is what we know, that formula for characteristic equation, since the characteristic equation is given by characteristic equation characteristic equation is given by formula. What is that? What is formula for this? Determinant of A minus lambda I is equal to 0. Here I is a unit matrix of order 3. Okay, this. Now what? Just write down the shortcut formula for characteristic equation. That is what? Lambda q minus trace of matrix A, trace of matrix A, lambda square, and plus what? Sum of minus of diagonal element. Okay, so first diagonal element is 1, so we ignore first row and first column. So you will have 2 1 2 2 is a first minor, and plus write down the second minor. So this is the second diagonal element, so corresponding to this diagonal element we ignore first column, sorry, second column and second row. So what are the element? 1 2 minus 1 2. Just write down 1 2 minus 1 2. Okay, and plus corresponding to the next diagonal element. So next diagonal element is 2. So we ignore third row and third column. So write down the minor corresponding to this 1 2 0 2. So 1 2 0 2. Okay. Now just close the bracket. So here lambda q lambda, here will be lambda q lambda square, so here will be lambda. Okay, so sign will be alternate, plus minus plus, and here will be minus. Write down determinant of the matrix A is equal to 0. Okay, so just simplify this. So you'll have lambda q minus trace of matrix A. Trace of matrix A is how much? 5. Just write down 5, and lambda square, and plus simplify this. So simplifying 2 to the 4 minus 2, just write down 4 minus 2 plus 2 minus minus here plus 2 and plus 2 and 2 and minus 0. Okay, into lambda and minus determinant of A. We found determinant of A is how much? 4, and this equal to 0. So further simplify this. So you will have lambda q minus 5 lambda square, and plus just simplify this. So this is what 2, here 2 and 4 and 2. How much? 2 plus 4 and plus 2. How much? 8. 4 to 6 plus 2 8. Just write down here 8. So you will get 8 lambda minus 4 is equal to 0. So which is your characteristic equation of the given matrix. But we want to find out what eigenvalues and eigenvector for the matrix A. So first of all, we find eigenvalues of this matrix. So just take a constant term 4. So we're taking here 4. Okay, 4 can be divided by 1, 4 can be divided by 2, and 4 can also be divided by 4. Okay, but what if I add or subtract? We must get here minus 5. Okay, so if I adding here, so 4 plus 2 6 plus 1 7, ज़्यादा हो गया. So 4 वाला काम नहीं करेगा. So इसको आपको क्या करेंगे अगर सब्ट्रैक्ट करते हैं तो -4 and -2 -6 and -7. अगेन -5 नहीं आ रहा है, तो 4 को हमको निकाल देना पड़ेगा. सो जस्ट रिमूव 4, जस्ट रिमूव 4 ए हमको काम नहीं करेगा, तो क्या करना पड़ेगा आपको? यहाँ पे इसको रिपीट कर देते हैं. सो
तो फिर -1 -2 भी लिख सकते तो -4.
हाँ,
अगर 2 को निकाल दो फिर करना.
yes, see here we remove 4, so we will have what? So here we will get -2 and -1. So this gives what? This gives -5. Okay, so this will work. So therefore we can write here lambda -1, lambda -2, and lambda -2 is equal to what? 0. So from this you will get lambda equal to what? 1, 2 and 2. Lambda equal to what? 1, 2, 2. So we have eigenvalues lambda equal to 1, 2, 2. How many eigenvalues are there? How many eigenvalues are there बच्चों?
3.
3 नहीं है, 2 ही है. ये तो 2 बार हुआ ना. तो आपको कितनी बार रिपीट हुआ ये 2 कितनी बार रिपीट हुआ? 1 टाइम्स रिपीट हुआ. तो आपको इसको एक ही बार काउंट करना है. सो हाउ मेनी eigenvalues are there?
2.
2. So number of, if I ask, find the number of eigenvalues of the given matrix. So how many eigenvalues you obtain? How many eigenvalues you obtain? बोलिए others.
सर 2 आए.
2 आएगा. यस, क्योंकि ये तो रिपीट हुआ ना, इसको एक ही बार काउंट करेंगे. ठीक है. So now let us move to the next case. So therefore we can write out, therefore lambda 1 equal to 1 and lambda 2 equal to 2 are eigenvalues of the given matrix. Eigenvalues of the given matrix. Given matrix. So how many cases will be there? How many cases will be there? So कितने? 2 cases will be there. Okay. First case, if lambda 1 equal to what? 1. If lambda 1 equal to 1, so we just let x1 is equal to, let x1 is equal to x1, x2 and x3 be eigenvector, be eigenvector corresponding to the eigenvalue lambda 1 equal to 1. Okay. Now since we know that the formula for eigenvector, since a minus lambda I is into x is equal to what? 0. Okay, where x is what? Column vector. So just replace lambda by what? 1. So therefore a minus 1 I, a minus 1 I, ax replaced by x1. Okay, so therefore you can obtain matrix A, your matrix A. In matrix A, just subtract 1 from the diagonal element. So you will have, just subtract 1 from the diagonal element. So 1 minus 1, you will get what? What is your matrix? Just first write down the matrix. Okay, your matrix is 1, 2, 2, 1, 2, 2, 0, 2, 1, then minus 1, 2, 2. This is your matrix. Okay, just subtract diagonal element by 1. So 1 minus 1 will be what? 0, and 2 as it is, and 2 as it is, 0, 2 minus 1, that is 1, and 1, then minus 1, 2 as it is, and 2 minus 1, that is how much? 1. Getting? So your x is what? Column vector, x1, x2, x3, and this equal to 0 is what? Null vector, just write down 0, 0, 0. Okay, 0, 0, 0. Just erase this matrix. Erase this matrix. Now what? Now our job is what? To find out x1, x2 and x3. Okay, so how to find out x1, x2, x3? Just be interchanging and find out the rank of this matrix. Okay, so we interchanging r1 into, sorry, r1 to r3. Okay, we interchange this matrix. So this matrix become second row as it is. So write down 0, 1, 1, we interchanging R1 and R3. So this become what? -1, 2, 1, and here 0, 2, 2. Okay, and write down your column vector x1, x2, x3, and this equal to right hand side 0, 0, 0. Okay, now what? We will make this matrix in row echelon form. Means what? There is first pivot element is -1 and below will be 0, below should be 0, and the second pivot element is 1 and below must be 0. Then third pivot element will be this. Means diagonal element must be non-zero, and other element here that will be 0. So we making in this matrix as a row echelon form. So let us see how to make this. So we, if I write here R3 minus 2 times of R2, then see what happen. So this become what? R3 minus 2 times of R2. So we just write down first row as it is 1, 2, 1. Here only R3 will change, not R2 and R1. So we write first row and second row as it is. So this is what? -1, 2, 1, and here 0, 1, 1. Okay, so this is 0. 2 times of this -2 and +2, 0, and here -2 +2 is 0. Getting? So write down x1, x2, and x3. So this is equal to 0, 0, 0. So what is the rank of this matrix? See here, there are two non-zero rows of the matrix. Okay, so there are two non-zero rows of the matrix. So rank of this matrix will be what? 2. So therefore we can write down rank of the matrix, rank of matrix A. इसको कैसा लिखेंगे? इसका नोटेशन, दिस इज रैंक ऑफ मैट्रिक्स ए, और सिंपली यू कैन राइट आर. So this is what rank of matrix how much? So number of non-zero rows of the matrix is what? 2. So rank of matrix will be 2. Okay, and number of variables, how many variables are there? How many variables are there here? 1, 2,
3.
3. So just write down number of variables. This is notation for number of variables is equal to, this is number of variables is n, and this is equal to what? 3. Okay, so we can find the dimension of solution space, how many eigenvector will be there corresponding to eigenvalue lambda 1 equal to 1. Okay, so therefore dimension of solution space we write down dimension of solution space, yes. Okay, so this, the formula is what? N minus r, but we have n is 3, r is 2, and this equal to what? 1. This equal to 1. So 3 minus 2 is 1. So dimension of solution space is 1. Means what? There is only one linearly independent eigenvector corresponding to eigenvalue lambda 1 equal to 1. So therefore here we write, therefore there is only one linearly independent eigenvector corresponding to eigenvalue lambda 1 equal to 1. Okay, so let us find out them. यहाँ पे मैं करता हूँ. So let us multiply this. So first element multiply by first element here. So first row to first column. Okay, so this first one is what gives x1 and plus 2 times of x2 and plus x3. Okay, x minus x1 2 times of x2 and plus x3, and this equal to what? 0. Okay, similarly for this row multiply करो. So this will what? ये तो आपको 0 मिलेगा. 0 times of x1 plus x2 and plus x3 is equal to 0. इसके इसको लिखने की जरूरत नहीं है क्योंकि ये सभी क्या है, जीरो है. ओके, सो यू ऑब्टेन दिस टू इक्वेशन. सो लेट अस राइट डाउन दिस इक्वेशन इन द नेक्स्ट पेज. सो कैन यू टेल मी, एनीबडी कैन टेल मी? So now we have two system of linear equation. Now we have two system of linear equation. Linear equations. What are they? Minus x1,
plus plus
then
2x2
plus 2x2
plus x3
plus x3 is
equal
equal
to
to
0.
0. Name this equation number 1. The next one,
0x1
0x1
plus x2
plus x2 plus
plus x3.
is equal to 0. Okay, name this equation number 2. Now solving equation 1 and 2. Just start solving the equation number 1 and 2. So from equation number 2, we have from equation number 2, from 2 we have what? uh, from equation 2 we have x3 is equal to what? Minus x2. Okay, now put this equation, put x3 in equation number 1. So putting this in equation number 1, putting this in equation number 1, we get what? Minus x1 and minus x1 plus 2 times of x2, and x3 is how much we obtain? Minus x2, and this is equal to 0. So we'll have minus x1 and plus x2, and this equal to what? 0. So from this you'll get x1 equal to what? X1 equal to x2. Okay, so therefore just write down your vector x1 is equal to, your x1 is what? x1, x2 and x3. ये आपका आइगन वेक्टर है. So this equal to x1 how much we obtain, x2 how much we obtain? Either x2 के प्लेस पे x1, हाँ either x2 के प्लेस पे x1 रखो, चाहे x1 के प्लेस पे x2 रखो, both are same. तो यहाँ पे मैं रखूँगा, देखिए x1 is how much? x2. Okay, but x2 is what? x2 is x2, and x3 is how much? Minus of x2. Okay, so this equal to what? I am taking x2 is outside, so you will get 1 1 minus 1. Okay, 1 1 minus 1. Therefore we write x1 is equal to 1 1 minus 1, or you can simply write down 1 1 and minus 1 is an eigenvector corresponding to eigenvalue lambda 1 equal to how much? 1. Okay, so this is for first case. Now we will have the second case. So let us move to the second case. Case number 2. Case number 2. What is the case number 2? If lambda 2 is what? 2. Okay, if lambda eigenvalue is 2, let x2 is equal to x1, x2, x3 be eigenvector corresponding to eigenvalue lambda 2 is equal to how much? We obtain 2. Okay, now let us move to the next page, then write down the formula for eigenvector. So since we know that since we know that A minus lambda I into x is equal to what? 0. Therefore, just replace lambda by lambda 2. Therefore, A minus lambda 2 is how much? 2I
2i
into x,
x2.
which is equal to 0. Now write down the matrix. Write down the matrix A. Just subtract 2 from the diagonal element. So just subtract 2 from the diagonal element.
लिखेंगे ना?
हाँ सेम पहले जैसा. Just subtract diagonal 2
और
from
सर वो
diagonal.
x2 लिखेंगे ना? a minus 2i x2.
Yes, this is x2. So 1 minus 2 is how much? 1. And 2 as it is 0. 2 minus 2 will be what? 0. And 1 as it is
1 minus 1
minus 1.
2
2.
0.
Yes, 0. Okay. So x2 is what? x1, x2, x3. Okay. And this is equal to what? Just write down 0, 0, 0. Okay, same procedure we have to follow. Okay, so we just interchange r2 and r3. So interchanging r2 to r3. Okay, this is notation for interchanging. Just write down your matrix. Your matrix will be minus 1 2 2. Okay, minus 1 2 0, then 0 0 1. So this is your matrix, and into x1, x2, x3, and this is equal to your null matrix 0 0 0. Okay, now what? So we want to make this element 0. So for this, what I have to do? For this, what I have to do? R2 and minus R1, then this will 0. Okay, so just write down which which row will not change. R1 and R3 will not change, only R2 will change. Just write down minus 1 2 2 and 0 0 1. Okay, so R2 minus this become plus and minus 1, so this is 0 and this is 0. And what? R2 is what? R2 is 0. This become what? Minus 2. Okay, this become minus 2. And write down x1, x2, x3, and which is equal to what? Which is equal to 0 0 0. Okay, now we want to make this 0 by using this. By using this, we want to make this 0. So we have r3 plus 2 times of r2, 2 times of r2. So this become what? Minus 1 2 2 0 0 minus 2. This first row and second row as it is, only third row will change. So 0, r3 is 0, multiply करोगे 0, so 0 plus 0, that is 0. यहाँ पर भी सेम आएगा 0. And then here uh, uh, no, r3 plus 2 times नहीं करेंगे, इसको ऐसा करें. Yes, इसको क्या करेंगे, जस्ट लिखें.
So 1/2 करेंगे ना?
Yes, 1/2 नहीं, बता रहा हूँ आपको क्या करना है. इसको so here 2 times of r3 plus r2. Okay, this operation we will use. So if I multiply 2 times of here in r3, so this becomes 0 and plus 0, that is 0. Okay, then 2 times of 0, that is 0, and plus 0, that is 0. Okay, now 2 times of here, that this become 2 and minus 2, that is what? 0. And we will have x1, x2, x3. Just write down right hand side null matrix 0 0 0. Okay, that is null column matrix. Here operation is r 2 times of r3 plus r2. Okay, not here. Yes, what is the rank of this matrix? So rank of matrix बच्चों A Rank of A is what? 2. Okay. Rank of A is 2, and that is R. Rank of A is what? 2. Getting? And the number of variables is what? Number of variables is equal to n, and which is how much? 3. Therefore, dimension of solution space, yes, this is n minus r, that is 3 minus 2 is how much? 1. So just write down, therefore there is only one linearly independent Li eigenvector corresponding to eigenvalue lambda 2 equal to what? 2. Corresponding to eigenvalue lambda 2 is equal to 2. Okay, so let us find out them. Just multiply this. So I am writing here, this become what? First row to first column multiply. So this is x1 plus 2 times of x2 plus 2 times of x3, and which is equal to 0. And here multiply, this is what? 0 x1 plus 0 x2 and minus 2 times of x3 equal to 0. Okay, so anybody can tell me this equation in the next row, in the next page?
Yes, sir.
Yes. So now we have two system of linear equation. We have two system of linear equation. System of linear equations.
Minus
Yes.
minus x1
Minus
x1
x1
plus
plus
2x2
2 times of x2 plus
3x2 2x2
plus 2 times of x3
x3 sorry
equal to 0. Okay. Name this equation number 1. Now tell me another one. 0 times of
0x1
x1 plus
plus 0 times of x2
plus
minus 2 times
minus
of x3
2 times of
x3
x3, which is equal to 0. Now name this equation number 2. Okay. So now solving equation number 2. So from equation number 2, we will have, from equation number 2, we have, so this becomes 0 and 0. So this becomes 0 and plus 0 minus 2x3. 2 times of x3 is equal to 0. So this implies that x3 is how much? x3 is 0. From this you obtain x3 is 0. Now put x3 in equation number 1. Putting x3 is equal to 0 in equation number 1. So we get minus x1 as it is, and plus 2 times of x2 and plus 2 times of 0 is equal to what? 0. Getting? So therefore minus x1 plus 2 times of x2 and plus here 0, and which is equal to 0. So from this you can say that x1 is what? x1 is 2 times of x2. Okay, we obtain x1 as 2 times of x2. So therefore x2 is what? Your x2 is x1 x2 x3. Okay, and this is equal to your x1, we obtain 2 times of x2. Okay, 2 times of x2, and x2 is as it is x2, and x3 is how much? x3 we obtain 0. Okay, and this is equal to what? x2 I'm taking outside, so this becomes 2 1 0. Here you can say x2 is what? x2 is arbitrary. If you change the value of x2, you will obtain different eigenvector corresponding to the eigenvalue lambda 2 equal to 2. Okay, so you can say that here where x2 is arbitrary. Okay, so therefore x2 is equal to 210 or 2 comma 1 comma 0 transpose is an eigenvector, is an eigenvector corresponding to eigenvalue lambda 2 is equal to almost 2. Okay, thus you can write on the final vector. Thus x1 is equal to how much you obtain x1, how much
सर
obtain.
लेमड़ा टू टू कैसे आया?
भाई लैम्बडा 2 पहले से दिया हुआ है ना, we obtain ना लैम्बडा 2, we obtain लैम्बडा 2 देखो
यस सर.
पहले निकाला है ना, तो है ठीक है. चलो, how much we obtain x1, yes, how much we obtain x1, 1 1 minus 1, 1 1 minus 1, and x2 is what, x2 is 210. 210 are eigenvector of a given matrix, of a given matrix corresponding to eigenvalues corresponding to eigenvalues lambda 1 is equal to 1 and lambda 2 is equal to 2 respectively. Okay, so in this way you can determine eigenvalues and eigenvector of the given matrix. I hope you understood this. Yes or no?
Yes, sir.
The problems are very simple, but only thing is that you should know the technique and procedure how to find eigenvalues and eigenvector of the matrix. Okay, we will have another problem. Next example is find characteristic value and characteristic vectors of the matrix. Your matrix is given by 0 1 0 0 1 0, okay, 0 0 1 0 0 1, then 1 minus 3 3, 1 minus 3 and 3. This matrix is given to you and you have to determine characteristic value and characteristic vector. Means what? You have to find out eigenvalues and eigenvector of this matrix. Getting? Let us see how to find. Solution. What is given to you? Just write down. Let your matrix A is given to you. That is 0 1 0 0 0 1. Okay. Then 1 minus 3 and 3. So first of all, what I have to find out? We have to find out just determinant of the matrix A. So just find out determinant. So this is 0 1 0 0 0 1 and then 1 minus 3 3. Okay, let's expand this determinant. So first one is 0. Okay, because first element is first row, in first row the first element is 0. So if you multiply by 0, so this will 0. Okay, minus 1. So you'll have 0 and minus 1. 0 minus 1. Okay, and plus this will 0. So you will get determinant is equal to what? 1. Determinant is equal to 1. Now find out trace of this matrix. So trace of this matrix is equal to sum of diagonal element, that is what? 0 plus 0 plus 3, and which is equal to what? 3. Sum of diagonal element. Okay. Now since we know that the characteristic equation is what? Determinant of a minus lambda I is equal to 0. Just write down, since the characteristic equation is determinant of a minus lambda I is equal to what? 0. Getting? So therefore we have equation lambda q minus trace of matrix A into lambda square and plus sum of minus of diagonal element. Okay, sum of. So ignore first column and first row. You will have 0 1 minus 3 3. Okay, and plus for second column and second row, just ignore it. You will get 0 0 0 0 1 3 1 3, and then next minor is what? Ignore third row and third column. So you will have 0 1 0 0. Okay, and into lambda. So sign will be alternate, plus and minus. Determinant of the matrix A is equal to what? 0. Okay, just simplify this. So this become lambda q minus trace of matrix A is how much we obtain? 3 lambda square. Okay, and plus, just simplify this will what? 0 minus minus goes plus 3 and plus 0 and 0. So 0 minus 0. Okay, and plus 0 0 0 minus 0 into lambda and minus 4. Oh, sorry, minus determinant of A. How much we obtain determinant of A? Determinant of A is 1, and this equal to 0. Therefore, we have lambda q minus 3 times of lambda square. And what is the remaining? 3 plus 3 lambda plus 3 lambda minus 1 is equal to what? 0. Okay. Now what I have to do? We have to find the roots of this characteristic equation. For this, what I have to do? Just pick a constant term and find possible divisor of this. So constant term is what? 1. Possible divisor of 1 is what? 1 को किससे डिवाइड कर सकते हैं? 1 से ही. ठीक है, 1 को केवल 1 से ही डिवाइड कर सकते हैं, एंड नो अदर एलिमेंट्स आर देयर, सो दैट 1 कैन बी डिविजिबल बाय देम. Okay, so what I have to do? We must have to repeat 1 how many times? 3 times. Yes, so आपको 1 को 3 बार रिपीट करना पड़ेगा. Okay, now subtract them so that you will obtain minus 3. Okay, so you will have minus lambda minus 1 first bracket, lambda minus 1 second bracket, lambda minus 1 third bracket, and which is equal to 0. So from this you will get lambda equal to 1 1 1. So how many eigenvalues are there?
1.
1.
Yes, only one eigenvalues are there. And how many times it repeated?
2 times.
Yes, 2 times it repeated. So therefore the lambda is equal to 1 is the eigenvalue of given matrix. Or you can write down lambda equal to 1 1 1 is the eigenvalue of a given matrix. Okay, is the eigenvalue not values of the given matrix. So there is only one eigenvalue. Okay, how many cases will be there? How many cases will be
One
there?
case.
One case. Yes, only one case. So let us move to the next page. Now, no need to write down case number if lambda equal to 1. Okay, so let x is equal to x is equal to x1, x equal to x1, x2,
X2,
and
X3.
x3 be eigenvector, be an eigenvector corresponding to eigenvalue eigenvalue lambda equal to 1. Okay, so since we know that the formula for eigenvector a minus lambda I into x is equal to what? 0. So just subtract 1 from the diagonal element of the matrix. So just subtract 1 from the diagonal element of the matrix. What is the matrix? Can you tell me matrix? Row wise bolo, just tell me.
0 1 0
0 1 0
0 0 1
0 0 1
1 minus 3 3.
1 minus 3 and 3. Okay, okay, just subtract one element from the diagonal. So a minus lambda is what? 1 into I x is equal to 0. So you will get matrix uh, 0 minus 1, that is what? Minus 1. Okay, then 1 0 0 here minus 1 1 uh, 1 minus 3. So 3 minus 1 is how much? 2. Okay, so and x is what? X1, x2, x3, and this is equal to 0 0 0. Okay, this is equal to 0 0. Now what? We have to find out rank of this matrix. Okay, so this is 0. So just using this element, we make this 0. So what is the procedure? R3 minus nahi. If I add this R3 plus R1, just add this. So you will get what? First row as it is minus 1 1 0. Second row as it is 0 minus 1 1. And third row will be what? R3 plus R1. This will 0. And R3 is 3 and plus, that is what? 1. That is what? Minus 3 plus 1 is minus 2. And here 2 plus 0 is 2. And into x1, x2, x3, and this is equal to 0 0 0. Okay, now what? We want to make this element 0. Okay, diagonal element must be non-zero. So I'm using R3 minus 2 times of R2. I'm using this operation to reduce third row. Okay, so which row will not change? First row will not change. So minus 1 1 0 0 minus 1 and 1. Okay, so R3 minus 2 times of R2. So R3 is 0. 2 times karenge to 0. Okay, so here R3 is minus 2 and minus 2 times is what? So this become minus 2 and plus 2. So this is here 0. Okay, and here R3 is how much? R3 is 2 and this is minus 2. 2 minus 2 is what? 0. And into x1, x2, x3, and this is equal to what? 0 0 0. And what is the rank of this matrix? There are two pivot elements. First one is minus 1, second one is minus 1. Okay, so rank of this matrix is what? Rank of matrix A is equal to R is equal to how much? 2. And how many number of variables? Number of variables are n equal to 3. Okay, therefore dimension of solution space S is equal to n minus R, and this is n is 3 and R is 2, and this is equal to 1. So there is only one linearly independent eigenvector corresponding to eigenvalue lambda equal to 1. So therefore there is only one linearly independent eigenvector corresponding to eigenvalue lambda equal to 1. So let us find out them. Just multiply this. So you will get what? Minus x1 and plus x2 and plus what? Plus 0 times of x3 equal to 0. Okay. And second row, from second row you will have 0 times of x1 minus x2 and plus x3 is equal to 0. Yes, can you tell me this equation?
Yes.
Now let us move to the next page. So now we have system of two linear equation. System of two linear equation. We have system of two linear equations. Okay. Just write down.
Minus x1
Minus x1
plus x2
plus x2
plus 0 x3.
plus 0 x3, and this is equal to 0. Name this equation number 1. And the next one,
0 x1
0 x1
minus x2
minus x2
plus x3.
plus x3, and this is equal to 0.
0.
Name this equation number 2. Now solving 1 and 2. So from equation number 2, we obtain what we obtain. This is what? 0 minus x2 and plus x3 is equal to 0. So this implies that x2 equal to what? x3. Now putting this value in equation number 1. So putting this value in equation number 1, we get minus x1 and plus x2 is how much? x2 is x3, and this is what? x3 is into 0 times of x3, that is 0, and this equal to 0. So from this you will obtain x3 is equal to what? x1. x3 is equal to x1. Okay, मतलब x2 x3 के इक्वल है और x3 x1 के इक्वल है, means what? Therefore x1 is equal to x2 is equal to what? x3. Okay, you can take any value, मतलब x1 x2 and x3 are arbitrary, so you can choose any value of them. So you will get, so let this is equal to what? 1. Say let this is equal to 1. Okay, so therefore you have x equal to 1 1 1 is an eigenvector is 1 1 1, or 1 comma 1 comma 1 transpose is an eigenvector corresponding to eigenvalue. What's going on? Corresponding to what? Eigenvalue lambda is equal to 1. Okay, so in this way you can find out the eigenvalue when eigenvalues are distinct and when eigenvalues are repeated. Okay, so I hope you understood this, how to find eigenvalues and eigenvector when eigenvalues are distinct and when eigenvalues are repeated for different matrix. Okay, is this easy for you? Yes or no? बोलिए.
Yes sir.
देखिए यहाँ पे आपको ये प्रॉब्लम आसान कब हो जाएगा? जब आपको आइगन वैल्यूज का रिपीट हो जाएगा ना, तो प्रॉब्लम आपको क्या हो जाएगा? आसान हो जाएगा, इजी हो जाएगा. ठीक है, अगर आइगन वैल्यू आपका डिफरेंट डिफरेंट आ रहा है, मतलब कि डिस्टिंग आ रहा है, तो मतलब आपको डिस्टिंग आज आया तो मतलब हर एक के लिए अलग अलग केस करना पड़ेगा। 3 रूट्स आएंगे उसके अलग अलग डिफरेंट रूट्स, तो उसके लिए आपको 3 केसेस करना पड़ेगा। अगर सपोज 1 रूट्स रिपीट हो गए तो आपको 2 केसेस करना पड़ेगा। सपोज तीनों रूट रिपीट हो गए तो आपको एक ही केस करना पड़ेगा। ठीक है। सो इट्स डिपेंड ऑन वेटेज ऑफ योर प्रॉब्लम, कि प्रॉब्लम का कितना वेट है, उसके अकॉर्डिंग आपको मैट्रिक्स आता है। ठीक है। अगर 8 मार्क का प्रॉब्लम आएगा तो ऑल द वैल्यू विल बी डिस्टिंक्ट, एंड सपोज दिस इज फॉर 6 मार्क्स, देन एनी वन ऑफ द आइगन वैल्यू विल रिपीट। एंड सपोज उससे भी कम मार्क का आ रहा है तो हो सकता है कि तीनों आइगन वैल्यू आपको रिपीट करके मिले। ठीक है। तो these are the procedure and how to find eigenvalues and eigenvector. So this is one of the most important topic for your exam. Okay. So you must know how to find eigenvalue and eigenvector of the matrix. Okay.